Hello, welcome back to IT Landy, session 2 around containers. Now, in the previous session, we spoke about how the container looked like. A quick recap, we said something like that. The container for Windows and Hyper-V, and we said like the difference is Hyper-V will not share the same kernel, whereas Windows will share the same kernel because it's based on the OS. For today, we're going to cover how containers works basically. High-level architecture. Container deployment and management tools, and then we have the runtime. Runtime is the OS. However, tool management, all they sit at the top. Like, for example, Docker Universal Control Plane. We have Docker Client, Docker PowerShell, Docker Compose, Docker Registry, Docker Swarm, and they sit on the Docker engine, and you have the operating system underneath it. So Windows container, we have the host user mode. Sit on the Windows kernel, hypervisor, which sit on the hypervisor. What they happen here, we have system process, we have container management. Container management, we have the Docker engine and compute surface, whereas the system process, which means the local security, etc, session management. And then we introduce the Windows container and how that will look like for us, something like the system process. And then we do application process. Then we add the hypervisor in this scenario, and then we expand around the Hyper-V container, and we see the Hyper-V container, we said like Windows kernels, and what did we mention earlier? They don't share the same one, so we have one Hyper-V container, and you go Windows, and you go application, and you go system, and then you have the, traditional optimized to run as a container. So these are the user mode, Windows Server, and you go virtual machine, and you can see the hypervisor where it sits. You go the Windows kernel shared or non-shared. Then startup performance, like one of the basic example, like Node.js with Windows Server Core. You go Windows startup 1 second, but hypervisor 3.3 seconds. A virtual machine can take another 5 seconds to run. These are basically some of baselines. Then we have Node.js with Windows Server Core. And then the earlier, if you remember, we mentioned the here server core. Now comparison between server core and nano servers, which is the lightweight, like we have Windows Server container 600 millisecond under hypervisor 1.7, virtual machine 3 seconds. So you can see the difference, and the reason why, because the nano is very lightweight. You only install what you need. Hence, this is the beauty of having a container. Now, density Node.js with Windows Server, basically core. We have first container 150 meg, additional container 75 meg, Hyper-V. Look at it. How big is this? 555 megabyte and 250 per container. Again, test performance on HP, ProLined, SL250, Generation 8, all the information all the way down. Yeah, result might vary depend on the hardware. Then again, Node with Nano servers, Windows container, Hyper-V. Look at the difference: 120 megabyte first container, 340 across the Hyper-V. Additional container 75, double on the Hyper-V. Node.js with core, again 150, 75 first and additional container. Look at the size: 555 for the first container and 280 for the subsequent containers. Overall, how that will look like for us, something like this. We go the host OS basically in this scenario, and under the host OS, we have container 1, container 2. You can see the container manager, host compute surface, host network surface, other surfaces. We have the WCIFS.system, NTFS.system, and configuration manager, and the host registry across. And then on the second one, we have the silo between virtual machine, registry, process, host, SMS, and then the kernel and executive files or SDKs. Hopefully that explained to you how it works. Next, we can cover how we can create a container in this container, okay, or Hyper-V. Thank you for watching, and goodbye for now.